Okay, so in this video we're going to introduce very quickly and very basic the definition of a logarithm. So we have a logarithm in any base. I'm going to work on a few bases in a minute. So the logarithm base b of a number x is the power you need to raise the base in order to get that number x. And the way to say it in symbols is that log base b of x is n means that the base b raised to the power of n gives you x. So this is what the logarithm means. It's a way to go basically backwards from an exponential function to find what is the input of the exponential function in order to get the output. But this is, for many purposes, how we need to solve some basic problems. So this is the definition. Okay, I'm going to try to just use that and no calculators to find what is the log base 2 of x. So what I just said is that the log base 2 of x, base 2 of 8, is going to be n if 2 to the n gives me 8. So I'm looking for what power of 2 gives me a number 8. And if you remember your powers, then 2 squared is 4, but 2 to the third power gives you 8. So the log base 2 of 8 is a 3. Okay. Next example is log base 3 of 81 is going to be a number n. Again, if 3 to the power of n gives me 81. And again, these are not terrible complicated numbers. If you're familiar with exponents and some basic numbers, powers, 3 to the power 2, of course, is 9. And if you do it one more time, 3 to the power of 3 is 27. But 3 to the power of 4 is 81. If you don't see this one right away, you can think of it like 3 to the power of 4 is 3 squared quantity squared, right? Because of the rule we've been using. 2 times 2 gives you the 4. So, and you know that this is 9 squared. So 9 squared, this is 9 squared. So that's 81. So that means that log base 3 of 81 is a 4. Okay. Go to the next one. This is a little bit tricky. It looks a little bit tricky because I'm mixing a decimal in there. So log base 2 of 0.25. This one looks a little bit trickier, but there's two things to think about. One, again, I'm going to do the same thing. I'll call that number n, and it's n. That means I'm looking for a power of 2 that gives me 0.25 as an answer. Now, that's not easy to see, but if you remember, 0.25 just is 1/4, so it's 1/4. So that makes a little bit, that helps me a little bit because I'm looking for a power that gives me 4 in the denominator. If again, a couple of videos ago, if you're coming from the sequence of videos, we talked about negative exponents. So 2 to the power of negative 2 is precisely 1/2 squared, which is 1/4. So my answer is this exponent, negative 2. That's my n in this case. Okay, so a little bit more work to do on this one, but it's doable. Last one from this set of examples is log base 10 of 1,000, and this is a very basic one. It's going to be a usual one we're going to use later, a common log. 10 to what power gives you 1,000, and easy to see, I hope, that this is a power of 3, right? 10 cubed gives you 1,000. So my answer is 3. So no calculators for these. We want to understand how the logs work. Okay, a few more examples in this short video. Log base 2 of 0.125. Of course, we know the trick for that one. We did for something very similar. The only thing is that 0.125, I hope you see it's half of 0.25, so it's 1/8, right? This is a familiar fraction if you're not used to it. It's not that hard to see that this is 1/8 written as a decimal. And then remember that what I'm looking for is a number n such that 2 to the power of n gives me 1 over 8. And again, remembering our exponent rules from before, we see that, oh, 2 to the power of negative 3 gives me exactly 1/8, right? Because this would be, let me write one more step here, because this is 1 over 2 to the 3, which is 1 over 8. So the exponent here that I'm looking for is negative 3. So 2 to negative 3 is 0.125. The next example is pretty similar. I have 0.001, and now my base is 10. So when my base is 10, it's pretty simple. I'm counting decimal places. You'll see that if you get used to this. 0.001 is really 1 over 1,000, which is, again, if you want to see it as a power of 10, what power should it be to get this? Well, it should be to the negative 3, right? We already talked about that. That 10 to the 3 is 1,000, so here it's just in the denominator, so it's a negative 3. Okay, now a couple more examples to get a little bit more interesting. Log base 2 of root 2. In the previous video, if you're coming from that video, I talked about fractional exponents. So root 2 is the same as 2 to the power 1/2. So I really have nothing to do here, because if you look at here, I'm looking for n. I'm looking for an n such that my base, 2 to the n, gives me root 2. But if I write 2 to the n, and if I write the root 2 like this, well, it looks pretty silly. I'm saying I'm looking for n such that 2 to the n is 2 to the 1/2. So of course, n is 1/2, right? So if you're familiar with fractional exponents, this is straightforward. If not, it might take a while to see what happened, but it's just reading the power of 2 that you need to use in order to get root 2. So when you write root 2 as a fractional exponent, it's 2 to the 1/2, so your exponent is 1/2. Okay, and my last example, I have, again, log base 2, and I have now an 8 here. And this is a bit trickier, but I have a square root, so we know that part. Again, the square root of 8 is 8 to the 1/2. And the interesting thing here is that 8 is a power of 3. Sorry, 8 is a power of 2. The power is 3. So since 2 to the 3 gives you 8, so I'm really just looking at this. Then let me use some space here. The root of 8 becomes the root of, let me change these colors, of, if I do this, see, color coded, the root of 8 becomes the square root of 2 to the 3, right? And now use the fact that we know, again, that 2 to the 3, but that square root, I can use it as a power of 1/2. So I'm writing the root of 8 is 2 to the 3 to the 1/2. And then, again, that review of exponents is going to come in handy. Here, in this case, I'm raising the power of 3 to the 1/2, so you multiply the powers. So this is 2 to the 3/2. And again, if you're looking for an n here, you're looking for a power such that 2 to the n would give you my root of 8, but I wrote root of 8 like 2 to the 3/2, and it comes straightforward. The n is 3/2. So that's a little bit more complicated, but just using the properties of exponents and the definition of logs that we gave at the beginning, it comes all in handy. So in the next videos, or eventually, in videos again ahead, we're going to be using log base 10. It's going to be called the natural log, and in that case we don't use the subscript. If I use log of 0.001, it's going to be understood if there is no base written, it's understood that it's base 10. So this is going to be the same as log base 10 of 0.001, and that would be a -3. Okay, so for example, log of 100 means log base 10 of 100, so that would be a 2. Okay, that was all for this one.